So as you can maybe see up on the screen there, we're just getting it set up so that this all actually, when the talk is over, we'll have all the slides up and everything ready to go right away as part of the publishing. So Shaun's just finishing that up here, and then we'll get right to the presentation. There we go.
Okay, great. Thanks for joining us. I'm sorry I didn't have the title slide up, so hopefully you guys are in the right place. But we're going to talk today about Conda. I'm Shaun. I'm a developer here at Esri, and this is Clinton Dow with me. He's a product engineer. We both work on the Python team. We work in the geoprocessing group, so we primarily do things in the desktop and server space. But as you've probably seen from the plenary today, Python's really expanding into many different areas in many different parts of the product. So yeah, we're really excited to have Conda in ArcGIS in a variety of. Oh, am I not? Oh, I can move it up. I was worried I was going to be like, better? Yeah, okay. So yeah, we're really excited to have Conda in the product now. We got it in last year, but now we have a UI. We've done a lot of work around it, and we're really trying to extend it into some new places so we can talk about it a little more in depth than we could last year. So just to save you from getting carpal tunnel, you can just go to this top URL, and that is the slides that I'm showing you right now. And it's good to write down this URL if you can, or one of these two URLs. The second one includes the demo that we're going to show you, some of the resources, because there's lots of links in this, right? So I'm not going to jump off to every one of the links. This just saves you some writing now, and you can go there now and follow along on your tablet or something if you're having a hard. I know these screens are they're a little on the dingy side in this room, but hopefully you can read it and follow along on your own device if you need to. Okay, so Conda. What is Conda? That's going to be our starting point today. So before I even get into Conda, I want to talk a little bit about packaging. Packaging is part of this story, and this is really coming at this from a typical ArcGIS desktop evolution. And in this evolution, there's no direct relationship here for a specific project, but this is more kind of how I see things often going for individual developers. This is often their path. Folks start out, often learning GIS first. They might be domain scientists, they might be analysts. They didn't necessarily go into it expecting to become Pythonistas. And they often start out by doing things like creating model builders, right? So they're starting on the left side of the diagram. And at some point they get a model that works well, they export that to a script, and then it's really cool, right? They can update some of the variables, just change some of the strings that are encoded in that Python script, and start kind of doing very initial programming. From there, it's often like, oh, look, actually, I can make these things generic. I can make these things as parameters to a script tool, and I can give this to someone else, and they can run it in their environment. Once you start getting a little more sophisticated, you start doing more things, you actually have a collection of things you're trying to run, and they have some relationship with one another, right? They maybe have some shared dependencies, they need to know about some shared state. You start looking at modularization, trying to make your code fit into some kind of context. Just like whenever you type import something, that import that you're doing is of a module, of a Python module. And then, lastly, there's this idea that you want to actually be able to package up that work. It can be modules, it can be tools. You want a way to take all that work and have it be a consistent resource that you can use and reuse and you can share with other people. And that's part of why Conda is interesting for us, is that it actually lets us get to that last stage. So what is this? Why do we care about packaging? Why can't I just write a script and be done with it? Well, one reason is that software is complicated. There's lots of dependencies in the software world, and one of the ways that we manage that complexity is by breaking it down into smaller subcomponents. And we often call those components libraries for developers, or also usually packages for people who are consuming those libraries. It also is partly a way of saving time, because if we can reuse existing code that's well tested and well developed, then we're often in a much better position than trying to start over and write it ourselves from scratch. But one of the really tricky things with this is that sharing code across groups is difficult. You have to have more or less the same environment as the person who wrote that code. And doing that, if you're working in a web context, it's a little easier because your clients are, they're interacting with a web browser, which still can be tricky if you have to support, like, say, an old version of Internet Explorer. But typically, you can control at least the development environment that you're building in. If you're deploying to server context, if you're deploying to desktop context, it's an even harder problem because you don't really know much about that environment that you're installing something into. And you often need to have exactly the same versions of packages as the person who developed, who did the original development has. And that's not always a trivial problem to solve. So if you've been in the Python ecosystem for a while, you probably already know something about package management, right? You've probably used pip, and maybe some of these other things like wheels and virtualenv. And so you're like, why am I here? Why can't I just use these things I know? Well, one of the reasons is that Continuum Analytics, the folks who have made Conda, they've really thought about a harder problem. Pip is great and virtualenvs are great if you can constrain the things you need to install to just Python packages. Where it gets tricky is you have some library which has dependencies on a C library, and that is considered out of scope for the Python packagers. The Python community has made a conscious decision to focus on packaging the things that are Python themselves, or maybe one step removed, but they're not going to package the system libraries for all the different environments, because for them it's like, well, the operating system should handle that, someone else should handle that. And it is true that on OS X or Mac OS now and on Linux, it's relatively easy to get the dependencies often. Now that might not be the case if you're in like a Red Hat environment, sometimes it's actually tricky, but generally they do have good ways of getting packages and it's a little bit easier. Many of the Python developers are on those platforms. They're not as concerned about Windows. But yeah, what about that other platform? What about Windows? Windows historically has not had this model. It uses a different approach for distributing software, and it's particularly hard to get packages integrated, as you probably know if you've ever tried to install some complicated software that runs on top of Python. So I've kind of mentioned this already, but really Conda came about out of the scientific community the scientific Python community noticing that there's a real gap, that they don't get what they need out of the core Python infrastructure, and they wanted to get packages into the hands of their users that weren't things that just pip could install. And the folks who started Continuum Analytics really know about this space, and I think we have a couple of them here in the audience with us today, and probably hit them up if you have questions about some of the work they do. But they really were pioneers in the scientific Python space. Some of the packages they wrote include things like NumPy and SciPy, things that you probably have heard of. Now those have very large contributor bases, but they were both started by folks at Continuum Analytics. So that's a little bit of background about it. It really does solve this hard problem. It knows how to deal with dependencies, and it's not just about Python. As you saw today at the plenary, it can deal with R, it can deal with a lot of other languages, and really by solving this problem well, it actually means you can use all kinds of different environments. We often have problems now that span multiple different software ecosystems, right? We might be pulling lots of different Python packages, we might be doing things with other non-Python packages. This lets us do that in one consistent environment. And being able to do that is that's a lot of what's happening today with the data science world, is that people are making workflows that integrate entire software ecosystems. And they're not, their starting point is not what are the packages in Java that solve this problem. Their question is what's the best way to solve this problem, irrespective of the various environments. So they can glue this together in one consistent way using Conda. So we gave this talk last year, and I like to look at the reviews and see what people said. See if there's things we can do to improve the feedback, improve how we give our talk. So I just wrote a quick Pandas script to look at the survey results. So here we're just pulling out the results for this talk last year. We're pulling together, there's some scoring fields that are on a Likert scale, 1 to 5 scale, and there's also a binary recommend, thumbs up, thumbs down. So we just kind of convert those and then generate a score out of that, right? Just adding the fields together and rescaling the binary value into a 0 or a 5. So I did that for this talk, and it's a little hard to read here, but you see mostly good scores, 30 is the top you can get. Then there's this one here, and you can't really read that. Can you guys read the screen? No, not at all. Would someone in the back be able to lower the lights a little? Maybe, I don't know. I don't know. I don't want to make it like a rave in here, but it might be a little easier to read the screen if we had I don't know if that's possible. Can you guys on that side read better now? Okay. If we can replicate the process on that side, we're going to be really in business.
If only we could package it.
Yeah, exactly. We need packaging for this problem. All right, well, I'll just continue on, and I apologize for, okay, oh, great. Oh, thanks so much. All right, well, it's still a little hard to read, but hopefully more folks can read it now. So, all right, so I looked at all these reviews, and there was one that really stood out here. They gave us a low review. So I was interested, all right, well, why did they give us that review? So we can look at the comment, see if they left us a comment. They did, and their comment was, there was no real basic explanation of what Conda does. It's just a package and environment manager. And so, you know, I like this quote from, you know, this is a good quote. It's from Terry Pratchett. If you don't agree with someone, try walking a mile in their shoes, because then you'll be a mile away from them and you'll have their shoes. So I did this, so I'm at this podium right now, so I got the location specifically of this podium, and then I generated a map of all the locations I could get to within a mile of where we're at right now. And you can see we got pretty good range. I could go a lot of different places, but I actually recommend that I would go here to the very bottom of the Cactus to Clouds trail, because, you know, this is a good defensible space. You could run up the mountain, good views. You're really in a good position with someone else's shoes as they're angry at you trying to come after you. No, I just wanted to give you that interlude because I think it's important that we do get across the idea of the fundamentals of this, and that we really, you know, it's something that you just have to learn once, but if you've never looked at the packaging space before, it can be a little confusing. You've probably used pieces of it and you know it to some extent, but you haven't really thought about it in the same way that Conda teaches you it. So really, you know, this idea is that we want to be able to consistently build packages. We want to be able to do that in a cross-platform way, and we want to be able to take those results and share them. That might be at the organizational level, it might be publicly, and we want to be able to do that not just with, you know, my favorite language, you know, it might be Python. We also want to be able to package things that lie underneath us, things like C. There's still a lot of Fortran code out there, R, other languages as well. And Conda does this in a pretty simple way, ultimately. It basically has a collection of files that are an archive that get extracted into what's called an environment, and rules which dictate what the archive, what files are necessary, what other packages are necessary for that package to get laid down. I also want to mention it's open source. We're using it, but you can use it for your own projects, right? So this is something you can take home. If you're making a new Flask app, you can use Conda for solving that as well. It doesn't depend on anything inside of the Esri ecosystem. So I mentioned a couple of words there. One of them is this idea of environments. The idea of an environment is you have a collection of packages that relate to each other in some way. So for example, when you open ArcMap or open ArcGIS Pro, we give you a Python environment or a Python distribution that's all the packages that come with, you know that you're going to have there at your fingertips. And in the Conda world, that's called an environment, and it's really the building block for managing any Python code. You can make the really great thing about environments is that they can be independent and isolated. So you often run into this problem, which is you have, you know, package A and package B, and they both depend on package C, but they depend on different versions of package C. And now you're stuck, right? You either say, well, I want to go with package A or I want to go with package B. You can't have both. Well, environments solve this problem. It means that you can create two environments, and that conflict can be resolved by using package A in one, package B in the other. Now, of course, you say, well, I want both. I want A and B and C. And of course, it can't fix everything, but it gets you a lot further along. It's very easy to switch between environments, and you can do things like have, say, ArcPy in every environment you're working in. How this works under the hood partially is that you have this idea of requirements, right? So you have a package and it explicitly encodes in it, what are the things I need to be able to run this? It might be, I need Python, I need this version of Python. It's a pretty simple idea. So where do I get these so-called packages? Well, there's Anaconda Cloud has publicly hosted repository. It has many, many channels. So there's a number that Continuum Analytics provide. Esri has a channel also on that site. We host all the packages that we generate. So right now, if you wanted to start a new project, you wanted to match exactly the packages that are available in Pro, you could do that. You could set up a new development environment that was decoupled from ArcPy and make sure that exactly the set of packages was going to work the way you expected. You can also host these things just using regular, web servers, IIS or Nginx. You can host it privately. There's an on-site offering, Anaconda Enterprise. I'll let the gentleman, John, who's here from Continuum Analytics, talk to you more about that. I don't know all the details on that. And also on disk. So you might have a situation where you need to walk the files through a firewall or go through some special process to get them inside the organization. You can just, these things are just tarballs. They don't have any magic underneath them. There's ways of getting, of dealing with that situation as well. And typically these packages exist in channels. So you have a channel, so for example, on the Anaconda Cloud, we have an Esri channel, and that's a place that we put up our packages. You then, when you're using Conda, you reference one of those channels to say, I want to go to this place to get these packages. And there's a Conda configuration file for that. All right, with that, I'm going to hand this over to Clinton here and let him show you using packages. Let me jump you over here. And oops. I think you can, yeah, okay, you're all set.
No problem. Thank you very much, Shaun. Just to clear something up, a tarball is just a zip archive, basically. It's just a Linux term. So if you're coming from a Windows world, that's all that is. So just to quickly take a look at some of the functionality that we have available in Conda. So first thing I just want to do is take a quick look at some things on the command line. I don't want to focus too much on this just at the moment, but we can just take a quick look right now by typing conda list and look at all of the different Python packages that we currently have installed. So as you can see, there's quite a few there. There's approximately 30 on a default installation, maybe a few less at the moment. But all of these working together is what gives you your ArcGIS experience. So it's not just ArcPy or ArcGIS scripting, but it's all these things working in tandem. And you can extend that idea into your tools as well. It doesn't have to be just these things that are available. It can be any of the packages that Conda makes available. So to take a look at what those packages are easily, we've added a package manager into ArcGIS Pro, which essentially acts as a user interface for Conda. I will also mention that there's a product called Anaconda that Continuum has put out, and it's fairly similar to what we've got here. They have a bit more functionality, and we're attempting to mirror as much of that as makes sense within ArcGIS Pro. So right now you're just looking at the very first release of it. There's a lot more functionality to come. However, it's a multi-part process in doing all of this. We have a lot that's happening behind the scenes, so it's not all entirely visible right up front, but it will populate more and more into the actual graphical experience as well. So as you can see here, those same installed packages are listed as installed packages. And so essentially you're able to drive some of the Conda experience right through the UI here. Now, if you're wanting to look at what you can actually add, you can click on the Add Packages and take a look through. There's quite a few here. I don't know the exact amount right now, but potentially hundreds of them. And the thing is that as you make your own packages and add them to the channels, they can be populated into this list so that analysts in your organization or customers that you're sharing with can just install from here. They don't have to be command line savvy or anything along those lines. So we've made a package here about the actual talk, and it's essentially, I'm just going to run it here to show how these things install. So I'll hit the install button over there, and it's for some reason getting overwritten, but like I say, this is a first version, so it still has a couple bugs to work through. But you can see up top here, the important thing that I want to point out about this dialog is that it tells you the dependencies of the package. So you can see here that we need Python 3.5 and scikit-learn, which is a machine learning package to run this package. And when I hit install, so I'm just going to agree to the terms, these packages are open source software, so they're subject to different licensing terms, so we just have to be clear on that and hit install. Then you'll actually, what's going on behind the scenes here is it's installing all of those requirements in addition to that package. And once that has installed, we can jump back to our interface. I'll actually just close that. And it showed up in here, yeah. So it's then populates into the actual project. Now that's not necessarily going to happen all the time. You have to arrange your package in a special way to do that, but we'll cover that a little bit more here. And then essentially just run it as you would a normal tool. So as you can see, just name it test. Is it .plt? Or?
It's PNG, I think,
Okay.
yeah.
And hit run. So it'll essentially handle the entire distribution, setup, installation, and everything that needs to be done to have this tool just run right out of the box. So I don't know if you've ever had one of those, oh, it works on my machine but not yours types of experiences. I've had many of them and they're very frustrating. This circumvents that entirely. You can just send the package out to whoever needs to use it and they can be running it within minutes and have result in the time that it previously took to even begin the conversation.
So what we did here is we just took a data set and we ran a machine learning algorithm that's not available directly in ArcGIS to make predictions about unobserved locations about these two particular species. And we just, in this case, just generated a picture, but you could just as easily generate a new geospatial data set to work with.
Correct, yeah. And then, so if we actually just head back to the package manager here, so we can see right now that there's just a drop-down that allows us to switch between environments. So I just want to quickly highlight, so we've got the talk here, but if I just switch to another environment, let's hop over to 3.6. You know, there's quite a few less installed packages. So by leveraging the environments, you can also control where those packages are going and essentially what they're able to communicate with. That's also present in the environment. So just to quickly take a look at environments right now, you can type Conda env list, which gives you that same list of environments and functionality that we'll be adding in at the actual release of Pro 2.0 will be to drive all these environments through the interface. But for right now, if I was to create a new environment, I would just want to Conda create, give the environment a name. So let's just call it test, and then use the clone switch, -- clone, to clone ArcGIS Pro -PY3. Right now, that's the main environment that drives the ArcGIS experience, and every environment that you would create would need to have the same packages. So when we do that, it'll run this whole thing, download all those packages, and I'm not going to show you that, but I just wanted to actually show you the command that allows you to create those. Now I'll hand it back over to Shaun.
Great. Thanks, Clint. All right, so just a quick review. One of the things that's different about this is that these environments, you have to get into them, right? So if you had ArcMap and you install it, it registers itself as the Python on the machine. So when you double click on a PY file, it opens up in the product. Now, one of the tricks there is that what happens if you have multiple products, right? You have different things that all need to talk to Python. Well, it's last one wins, and that's an unfortunate situation. So one of the things that's good about this is this isolates it from the system install. It has no interaction with anything else going on in the system. The trade-off is that you have to get into one of these environments explicitly. We have some shortcuts included in Pro. They're in the program group. So if I go here and say ArcGIS, oh, I guess I can't do that. If I go into the program group for ArcGIS Pro, there's a couple of new shortcuts here. There's you probably can't read that in the back of the room, but there's two. There's one called Python command prompt. That's going to initialize a new command prompt session that's already inside of Conda. And then there's also just getting directly into the Python executable, right? So if I wanted to jump into run some ArcPy command directly against ArcGIS Pro, I could just click on that and run it. So that's kind of the simple way of doing it. You can also do it from the command line. You basically just go into the location, this ArcGIS bin Python scripts directory, and then you can run this activate command. This is part of Conda. And then we also have some helper scripts, one called pro env that just does the same thing, but always for the active environment that's driving ArcGIS Pro. And then we have one called ProPy that does the same thing of getting you into the Python environment. So just a quick review, Clint kind of already showed you this, but Conda has a command line interface, and it uses the same modern approach to command line interfaces, which is kind of this noun-verb architecture. So you type in Conda space, the name of the action you want to take. If you just do Conda -- help, it'll give you the list of all the things it knows how, all the verbs, all the things it knows how to do. And if you then did like Conda space info space -- help, it'll give you detailed info on that specific, detailed help on that specific command. So it's really, Conda info is a good command because it gives you the state of the world, right? What are the environments I have? If I go back here and, oh, this thing's still going.
You can Control C it
okay.
Just to show the command.
Okay, so if I do Conda info here, I'm going to get some information, right? What are the version of Conda I'm using? What Python are we running? And then where are we getting our packages from? These are this idea of channels, right? Where are the locations at which I can find packages? All right, so that's all included in that Conda info command. So Conda list, we already showed you that. Won't go over this too much, but we got a few things, right? We got the package name, the version, its build information, and then this also tells us the channel it came from. So you see a few of these here are marked with Esri in the last column. Those are the ones that are hosted in our Esri channel. That's what that means. The ones that say defaults here, those are the ones that depend on the default channel, the one that Continuum provides for all installs of Conda. All right, so with that, we want to take the time to do a little bit of a deeper dive. So we just showed you installing a package and running it, right? So now we see that we can do that. Well, how do we make one of those, right? What do we need to do to take some code we have and convert it into a package? Well, Conda packaging, it's not that complicated. The basic idea is you make a recipe, and the recipe describes the instructions to build the software, right? It isn't that hard. You basically need to tell it, where do you go to get the code? It could be GitHub, it could be a local resource, it could be an archive somewhere. What are we building? What's the name of the thing? What do I want to tell people about it? What version is it? And what does it depend upon? This is what we talked about with the dependencies, right? We have to explicitly enumerate the things that our package depends on. And then finally, we run this conda build command, and that generates a new package for us from this recipe, and we can use it in a variety of ways. So this is what the package metadata looks like. If we have a package that we wanted to create, this is the one that we were just looking at a minute ago. This is its name. That's what showed up in the UI. This is the GitHub URL that it exists at. And then we've included its dependencies. There's a couple other things I didn't include on the screen here, but they're pretty basic things. They're like, give me some details about this package. That's it, really. And then there's a second step of making a file which points at the right resource. I'm not sure why my background's not showing up here. But basically you tell it, I want to build this package, and you point at the location where you've got that meta.yaml file and a build set of instructions. And then the final step is you just say, I want to upload that package to some location. So in this case, it's set up to default upload to anaconda.org to my channel. So I could jump over to a new tab here and then go to anaconda.org, my channel, and there it is. There's the one that we just installed, right? So it would get uploaded here to the Anaconda cloud. Someone could download it just using Conda, nothing to do with ArcGIS, but they could also use it inside the application, provided that they were accessing our channel.
And it's also accessible to anyone with Conda not in ArcGIS as well. So if you package things that may not even be tools, but could be things like metadata or anything along those lines, that could be sent out to multiple users, even if they don't have the application itself installed. So now I'll just take a quick tour of how we can actually create packages here. So,
did you want this?
Oh, right, yeah, sure. So I'll just quickly show the meta.yaml. That stands for yet another markup language, and that's kind of how I feel whenever someone says another markup language. But this one's pretty straightforward. I feel like it's just a list, very similar to how Python is structured and separated by white space. So as you can see here, you're really just setting the metadata, which is why it's called meta.yaml. So like package name, version, You can track how many times it's been built, so on and so forth. And then as Shaun mentioned, this is pretty cool, I think. You can actually set the source of your code to a remote repository like GitHub, for example. So what it's actually doing here, it's not pulling the code from your computer, but it's pulling the code from GitHub. So that's pretty important if you're working on a large team. Suddenly, that whole process can just be handled from the central repository collection rather than everyone having to pull down everything onto their local machine. And it, again, just that slight increment of speed in the development process when it propagates out to multiple people, multiple projects, it really starts to add up very, very quickly. As we go further down here, then you can see that it's also, we've specified the requirements in it. So there's the two different steps, basically, the package building and then the package running. So setup tools, if people have made pip packages before, put them on the Python package index, you'd likely use setup tools to have created that package. And Conda does leverage that as well. So as you saw before, there's the channels list. You can also install pip packages just by using pip install as you normally would. And that's important because Conda, it provides more of a curated list as such, and Anaconda provides that entire collection on your machine. But if you want to go outside that, then and outside ones that are installed on channels that are available that way, then you can still use pip too. So there's a large number of them that are present only in pip, but it's getting ported over at a quick rate right now.
One thing with the separation, the reason you might want to have build dependencies is you might have a testing harness you want to run when you're building the package. You might have extra stuff. Your users don't care about that, right? But for the building case, you would want to run the full test harness, do all the extra evaluation. So that gives you that ability to separate out those dependencies for the test case versus the installation case.
Great. And yeah, just a little bit more information there, but there's also on the Conda site, they have documentation about this entire thing. There is extra information that you can include in there, I believe even like a test suite, so it knows not only which to download, but also how to run them, and it can do that all automatically for you. Now, when we were talking about channels, they come from the Conda RC file. Is this, oh, it's freezing up on us. There we go. So here we've just added the extra channel that's Shaun's personal channel, SCW, and right now we've only got Esri and defaults in there. So Esri is of course our channel, and then defaults is the packages that Continuum Analytics provides. But if you're wanting to leverage more channels, there's plenty that are available on anaconda.org, but also ones that are created. Even if you just have a local web server, you can point the channels at that and it can load packages off your local web server as well.
One thing here too is that the order in which they're listed here is the priority, right? So if there's the same version on the Esri channel, defaults channel, Esri's going to win here because it's higher in this list.
Right. Yeah, and that's actually quite important. When Shaun was showing earlier, there's the packages that have Esri in the right-hand column. They're coming from that channel, and in some cases that's because we've had just a history of having to custom compile some things like NumPy, for example. And as we move forward, we're going to try and reduce that custom dependency and move more towards the open packages to make it just a complete case where you don't have to have custom compiled Esri components to use the tools. Now, if I just jump back over here, oops. So right now, I'll show you how to actually build a Conda package. There's just an important thing that I want to.
I think you want that one, sorry, because that's not activated. Yeah.
Ah, my bad. So you can see here there's the root environment, and it's not in the envs directory. So that basically means that everything that's in the root environment is accessible in the ones that are inheriting from it, essentially. So when I'm installing a package like Conda build, which is a package that's provided by Continuum themselves, it will install into that root directory. And also, if you're upgrading Conda, for example, you'll only have to upgrade it in that root directory. And that's a little bit confusing at first because it's not in that EMS folder, but it is still a fully functional Conda environment. So that just goes to show that there's not magic happening here. It's exactly the way that a standard Python environment works. It's just doing it for you. It's automated, but it's not. When you get down to it, it's really not different than what you're doing with normal Python. So anyways, I've already installed that. I'll just show you the command. So it would just be conda install, and then you want to specify the name of root, and then install conda-build. I'm not going to run that right now. It'll just take a little bit of time. And we've already gone ahead and done that. So, not in Linux. If you look in the actual folder that mirrors the repository that's being pulled off GitHub right now, you can see that there's all of these other files in addition to meta.yaml, such as setup.py and manifest.in, and those are what are being used by the distribution utilities library in Python to actually create the package that would be deployed as a pip package, and then Conda's wrapping that with more metadata to do the SAT solving and essentially make sure you have all of the correct packages installed there. So if you can just take a quick look at setup.py. It's his machine, so I'm not sure what all the directories are and everything. There you go. So yeah, basically here it's a very standard setup recipe. You can see that we're just importing distribution utilities and setup tools, and those together provide a lot of that functionality to create the pip package. And then just specifying a little bit of information that we need about it, like the version number description. I guess we've got his name and my email here, but yeah, basically this is where you're giving all that information that's populated then onto the Python package index, when you see all of that information. So you kind of have to set it in a few places, not only meta.yaml, but also setup.py, and then they'll work together to get everything balanced out. And then once that's all done, all you have to do is run.
Sorry, I have to switch back. I forgot to switch you into root.
Oh, it'll still run.
Oh, okay.
Yeah, so, and that's actually a good point. So we don't have to switch back to root because it's inheriting those packages from root. So if I switch to any of those other environments, like any of these ones, they would all work with conda build, even just installing it that one time. And then you just have to specify the directory that setup.py lives in, hit enter, and it'll go through all of this process of essentially downloading everything that you need, getting the source code from the Git repository, putting it all together. If you had that test suite, it would then at that point in time run the tests to make sure everything's good to go. And then once it is, we're on conference Wi-Fi. This might take longer than anticipated, so I'll just switch over here. Yeah, so we've got Python here. So this is the actual Python directory is the root directory. So we can see in our packages folder, this is where everything is stored, that all of your packages, and all they are is, like Shaun said earlier, a tarball zip file. You can just look through, you can see that there's different versions of Python that have been installed, and all of these other packages that we're using in ArcGIS. He's got quite a few on there because we've been doing a lot of testing, so all of those wouldn't be present. But conda build is in there, and then when you run it, all this stuff that's scrolling through the background is doing what I was describing when it's packaging it together. Then it'll end up in this conda -bld for build directory. And then you can look in the Win64. Seeing as we built this on a 64-bit Windows machine, it knows it's smart enough to automatically pump it into there. And then it just creates this Conda Dev Summit tarball. And then that is what Shaun uploaded and showed you on his Anaconda channel. So all of that process is very quick. You really only have to set up the workflow once, and then you can utilize it again and again and again. So again, it's just one of those cases where it's incremental savings of time over and over and over, and it's kind of a snowball effect. Was there anything else on here that you wanted to show, or go back to yours?
No, I think the only other thing, just really briefly, if you've looked at Python before, you know, you've seen all these things. If I look in one of these environments, these things all look pretty familiar, right? I've got these directories and scripts, and there's some things in scripts. All that Conda's really doing on top of it is just adding this additional directory, Conda meta, and that really just includes, it's really not that much, you know, going on here. If I look inside, so there's one of these for each of the packages. If I open up this one that we just added, it's a list of, you know, where did this come from, what the channel it was installed from at, and then what are the actual files that reference that are installed on this machine. In this case, it's only a couple because it's all contained inside of an egg file, but this is basically it. It's just it's just a recipe that includes the instructions for where to lay down these files on disk. Okay.
Oh, actually, maybe just the pin file too.
Oh yeah, sure, yeah. Yeah, so this, actually, let me just open it up here in this other. Be quick here. So this is one other file we wanted to show you really quickly. I guess I have it open already. It's open to read only. Okay, so this is another thing you can do is you can say, okay, I've made an environment. I don't want someone mucking it up, right? I know something about it. I know that I need for this particular application a specific version of a package. If a new one comes out, I don't care. I want it to stay with this old version. So that's what this pin file lets you do. It lets you say, these are strict dependencies, and Conda will respect that. It'll look through these things. You can see that some of these I just say, well, this environment always has to have the future library, but I don't care about the version. There's other places here, like here with SciPy, I'm specifying a specific build number. I know that I've made a custom build of it, and this environment both has to match that build and match that version. So we're being very strict. We're saying you can't put a new version of SciPy in this environment unless it exactly matches. And that's to protect, like, if you have some code that depends on a specific ABI, you don't want that to get shifted out from underneath you. So that lets you do this as well. Okay. Awesome. So just to wrap it up, we looked at the Python package manager already. So how can you use this? Today you can use a bunch of stuff. You got all the SciPy stack sitting there. It's on everyone's machine. It's on the server. It's everywhere. It's great. But if you want to use Conda, you can extend that even further. You can get a bunch of new packages onto the machines. You get the root environment. You get the Conda environment that's driving ArcGIS Pro. We're also, we continually look at the set of packages that are out there and evaluate, is this something we want to put into the product? Now the thing is, we don't put things in there that we're going to take out ever, so we have to be very careful about that, right? Sometimes we get stuck with a package where we're like, well, it kind of sucks because someone else has come up with something newer, but we made a decision to go with whatever the first thing that came out was. But for example, we did just add the requests module, so if you do any kind of web requests work, this is a much nicer interface than if you've used urllib 2 before. And we looked at the Python package manager and Pro, so maybe you have users, maybe you are able to do this development, but then at the time of deployment, you can put that in the hands of the analyst. They don't have to go through the command line. They can just go through the package manager and Pro and get your code onto their machines. So yeah, just get packages, expand what you can do. This is also a really great way of distributing your work. If you've ever had to do that before, you probably know how difficult that is. Where can you run this? At ArcGIS Pro 1.3, Conda is the Python install, and one of the things is that at 1.3 we shifted to including a full Python in every install. Prior to that in Pro you had to install a separate package. That's no longer the case. At Pro 1.4 we upgraded the Python to 3.5, which is the current release at the time of that the Pro 1.4 release. There's 3.6 out now, and we included this package manager that we've been showing you today. And the package set that's on there is very current, so you shouldn't have problems with other packages being incompatible with it. This is also included in Enterprise, so you can use Conda for managing packages on the server side. Now there's not an exposed interface, you still have to do that through the command line, but it's there, and it's much simpler than it has been in the past to get packages into that server environment. And then if you've seen any of the stuff with the ArcGIS API for Python, that also depends upon Conda for getting its dependencies. You can put that into your Pro environment, you can use that in various places, but that has no dependency on any desktop or server product, right? So you could use that on Mac, on Linux, in other kinds of circumstances. All right, so what are we looking at doing next? So for Pro 2.0, which is coming out not too long from now, we're going to be extending that UI for managing environments and channels, things that you can't directly do through the UI experience right now. We're looking at making resettable environments. So if you had someone who maybe made some changes that caused some breakage, they have a way of getting back to the initial state. Historically, the story for that had been very poor with ArcMap. It might be like you pip install a package and then suddenly ArcMap doesn't open, and the answer is to like reinstall. It's not very fun if you've been there before. And then the other thing we're looking at is making like a really, really small mini version of Conda that just includes the basically it packages everything up into standalone executable. So there's some circumstances where it's really useful to minimize the number of files and the total size of the distribution. All right, that's it. I have a section here that's on resources. There's a few other talks that are going on that might be relevant to you. There's a talk tomorrow on data science using R and ArcGIS. If you saw the demo today, using Conda to install this R package, we're going to go a little bit more into detail primarily about using R for data science problem solving, but it does connect up with Conda. And then we've got 2 sessions in demo theater back-to-back, deploying geoprocessing tools as Python modules. So in that kind of pipeline, going from starting out with Model Builder, ending with packages, modularization is really often a prerequisite for that. It's kind of where you want to go before you get to packaging. And then just after that, in the same room, Clint's going to be covering actually using...
Side by side, but
close
room.
Okay. So going to be covering actually Conda in other parts of Conda that we didn't cover here today. And then finally, Brendan, who is a longtime Esri aficionado who actually works at Continuum Analytics now, he's going to be presenting a presentation on all the things that Continuum Analytics is doing beyond Conda, right? So Conda's this base package, but Continuum Analytics has a lot of really amazing offerings. Many of those are open source packages. They also have other things going on. So he's going to kind of talk about that ecosystem and the things that are happening in the open data science world that Continuum Analytics is really at the forefront of. So just a terms disambiguation thing here. So if you have someone ask you, well, what is what? So Conda's the command, mini Conda's that distribution that we lay down. It's the minimum set of things you need to drive a Conda executable. And then Anaconda is this fully hydrated set of 200 plus packages that includes lots of things for doing data science, doing all kinds of stuff. And then there's a few products. I only mentioned one here, but Continuum Analytics has a number of products for extending that experience. If you wanted to bring this whole stack into an organization, distribute it, do all kinds of really cool stuff. They have some products for doing that. And there's a few resources here. I'll let you look at these offline in another time, but just to kind of take you further and look in a couple other directions. All right, I think with that, just thanks to my team here at Esri who helped put this together, and Continuum Analytics for creating and open sourcing Conda. And if you have any feedback, iOS app, Android, please give us feedback. But be warned that any feedback I might incorporate into next year's talk, as you saw today. So that's my only warning. But yeah, if we have any questions, we have a few minutes for questions now. Thank you.
Can we bring up here, I'll bring it up. Welcome.
Yeah, thank you. Great presentation. I was curious. I got the part where you can use Conda to install packages from one machine to the other when you're online. What about offline installation? Does it make it easy? Let's say I have a product that I want to install on a machine offline. Is that easy to do?
Yeah, if you have the actual tarballs, all it's going to do, you can you say Conda install and point it at one of those archive files, and it will know how to install that. Now, the question is, if you had like that package then depended upon a lot of other packages, you have to have them somewhere locally. But that locally could be like on a network share or something in some context where you're in a firewalled environment where you can't talk to the external network, but you still have internal networking services. You could stand up a channel inside of that context, or if you were really invested in it, then Continuum has a lot to integrate that whole stack into that environment. But at the bottom, you could just install a single archive by saying conda install, pointed at the tarball, and it'll install.
After you run the conda build, you can also with Python, you can use Python-m to just run a Python module. And if you run Python-m http.server, it just puts up a HTTP server in that directory. So if you actually just go into the conda-bld directory and then run that command there, then essentially it's creating a repository server right on your local machine. So even if it's not connected, then you can still utilize that functionality as well. Oh, got one in the back here.
Does Conda? No?
I think.
Sorry.
Click that up.
No, it's not.
Oh, there you go.
All right. Does Conda offer the ability to kind of toggle between 32-bit and 64-bit Python installations?
That's a good question. Yeah, so by default, you create one of these root conda installations, and you have to make that decision up front. So you can install a 32-bit version or a 64-bit version, and everything from that point on is bound to that specific case. It doesn't, in a single environment, allow you to inject both 32-bit and 64-bit packages. But because the environments are cheap, it's not too hard to stand up two separate condos that have exactly the same environment but replicated across 32 and 64-bit. Yeah. Anything else? I've got one over here.
All right.
The mic running.
It's good. I need some exercise. Too much development.
Hi. So with regular desktop, and you're installing, any installation of desktop, and it installs your Python into a Python 2.7 folder, blah, blah, blah. Is there any way that you could kind of make those work together? Because this, has a whole different, place to install, and then if you have Pro and desktop on the same machine, I just see this getting really complicated. So how can we make those work together or not?
Yeah, so you definitely can, but you have to be careful. Like I mentioned before, it's easy. You can say pip install some package. It depends on a new version of NumPy, for example, and it will just happily install that. It doesn't know anything about what else might be dependent upon that old version of NumPy. And then you go to open up the application or import ArcPy, and it's crashing, right? So you do have to be careful. It is possible. It takes some, it takes some you have to be pretty strict about what you're doing, because when you go to add new packages. So imagine you've got two things, right? You've got your conda install, and you've got your ArcMap installation of Python. So basically, you could stand up a new conda environment that exactly matches the versions of the packages that were in your ArcGIS installation. And then it's possible to cross-reference those things. So you would use that conda install, you make sure that the packages you installed there are exactly the same. And then you could add new stuff on top of that in conda. And then you can cross-reference those two environments. There's these things called PTH files. It's just the letter, it's path without the A. And so basically you could add, if you look inside of that, Python 2.7, ArcGIS version, there's a lib site packages directory. That's where actual packages live inside of that directory. There's a ArcGIS version, file there called, ArcGIS 10.5.pth. You can copy that into your site packages in that conda environment you created, and then you can import ArcPy at that point. The nice thing about doing that is you're not mucking with that base installation of Python that came with ArcMap. So that's the approach I'd recommend, because then you have this nice, you can still import ArcPy inside that other context, but you don't have to worry about affecting any of the system state and potentially reinstalling. Yeah.
We're also going to do a bit more documentation and blog posts and stuff on Conda, so that's actually a very good topic. So.
Yeah.
Any other questions?
All right, great. Thanks for sticking it out, and it's great having you all here.